Yes. Yeah. Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yeah, it's perfect.
Yeah,
Thank you. Yeah.
Audible.
Yeah. As part of today's PYSPARK with introduction, I'll be discussing, okay, what is Apache Spark? What is Apache Spark? Why PySpark?
PySpark is a library of Python which
Okay.
provides a Spark interface for.
Need for PySpark. Spark. Difference between, see, which one is mostly like Spark, Python, and Scala? PySpark features. A real life usage. Usage of PySpark. PySpark job market. Yes. Apache Spark. See, Apache Spark, right? It's an open source. It is an open source distributed cluster computing framework introduced by Apache Software Foundation, right? It's an open source distributed, yes, cluster computing framework. The cluster computing framework, right? Yes. Open source distributed cluster computing framework. It is introduced by Apache. It is a general engine. I can say Spark, Apache Spark, right? It is a general engine for big data analysis, right? For big data analysis, for big data processing and computation. It is an engine for big data analysis, processing and computation, right? So why, if you say why PySpark? Yeah, someone was saying, right? Why PySpark? Yes. Yeah. PySpark, it is a Python API, right? It is a Python API. Yes. To use a Spark. To use Spark. See, I'll make it clear. Spark is an execution model. Spark is an execution model. Like this execution model can be implemented by multiple languages. I was saying using Python, using Scala, using Java. Mostly preferred is Python and Scala. So what is the difference I'll be discussing, right, between Python and Scala is Python API to use Spark. So I can say PySpark, it's a lightning fast technology that is designed for fast computation. Yes, PySpark is one of the demanding tool among the data engineers for working with the bigger data sets, right? Yes. Yeah. PySpark is used for, yes, PySpark, right? It is used for creating data pipelines. It is used for creating data pipelines. So it's a PySpark, it's a data flow language, I can say. It's a data flow language. The output of one will be the input to the next one. So it's a data flow. Creating data pipelines. Next. Ingesting data into database, ingesting data into a database, right? And here PySpark supports many, okay, running ML algorithms, running machine learning, right? ML, running ML algorithms using this. So it has got rich set of libraries available. PySpark has got rich set of libraries for this ML algorithms, not only for this, even working with graphs, and working with streaming, micro batching this way, working with data streams, micro batchings. Yes, creating data pipelines. Yes, ingesting data into a database, creating ML algorithms, working with the graphs, working with data streams, DS streams, right? Yes. Micro batching, we said it. We want a quick updates required for every 10 seconds or every 30 seconds. I want updates, right? That is what micro batching, batch and micro batch. So generally this Hadoop, Spark, all this, they are used for batch processing, for batch applications, right? But here using this Spark, like using this data streams, right? Here micro batching can be done, right? You want quick updates, right? For every seconds of or minutes of time, right? Yes. So if we talk about the need for PySpark, so here, if you see huge amount of data, you see like huge amount of data is getting generated, right? So this whatever data yes contains some hidden patterns, unknown corrections, market trends, customers' preferences, and other useful information, right? So I want to extract some valuable informations from the available huge data, right? So we require some efficient tools to work with this, right? This kind of operations on this huge data. So previously, if we talk, we have got some tools, but as compared to that, so this is the most efficient, right? Tool, like PySpark is the most efficient tool. It's a scalable and flexible tool to crack the big data and gain benefit from this flow. So PySpark. So it's combining Python and Spark. So combination of Python and Spark will be the most efficient way for the world of big data. That's why Apache Spark community has come up with a tool called PySpark. PySpark API to use Spark. PySpark like combining both Python and Spark. Okay. So generally, most of the students have queries, right? And they'll be asking which one is preferred or which one is mostly used, right? Spark, Python, see, Spark with Python or Scala. So Python or Scala, right? See, Spark can be coded with multiple language. It supports multi-language supports. Scala language. Spark can be coded with Scala language, Python language, Java, and R language. So it supports multiple language, right? So where you can code. So mostly used languages, mostly preferred languages are Scala, Python, and Scala. So when Spark was introduced, right, totally the implementations, everything was done using Scala language. But if you see from last 2-3 years, the usage of PySpark has increased a lot. Means Spark with Python implementation, where Python has got a rich set of libraries for this, especially like ML algorithms for graphs and for data streams, right? Especially ML, Python has got rich set of libraries for this. Yes. Even both Scala and Python both are. Whenever I refer Spark, see, speaking frankly, right? So default Spark is the Scala is the native language of Spark. Scala is the native language of Spark. Spark by default built using Scala language. Okay, previously we see in the year 2016, 17, 18, in 19, right? If you see this, mostly the Scala language is mostly used for implementing Spark. But these days, as this ML algorithms applications, right? So Python is mostly chosen, means these days, right? Even industry is choosing Python. Whatever you can do using Scala, right? All that you can do using Python also. All right. This Scala also, it supports like multiple like features. It has got Scala also has got multi features, like it has got features of object oriented functional programming, right? And script based, right? But as compared to Python, the main thing we see like modular programming, like a lot of modules concept you see in Python, right? So these days, like PySpark has got great demand, like Python with Spark. Okay. So if you see the differences between this Python, right? Python and Scala. So this whatever the Spark functionalities, right? Spark related APIs, Spark related functionalities are going to be same in all the languages. Spark fundamentals like Spark API, Spark functions, everything will be same. But only the coding, right? Coding is going to change, like using Scala or using Python or using Java or using our language. For example, if you want to define a variable, if you talk about Java, Scala, Python, Java, Scala, and Python, right? Just in programming part, right? If you say, if you want to define a variable like int x equal to 10 here in Java. In Scala, we won't say what is, okay, we say we use var x equal to 10. In Python directly, you can say x equal to 10. So whenever you are coding this Spark, right? Yes, the programming is going to change. Yes, the variable defining the functionalities, the functions, the collections, the types, right? So, but whatever the Spark related things, the behavior won't be changing. The Spark behavior will be same, but only the coding, right? So mainly main differences of Python and Scala. Scala is the only language which is used for Spark environment only. Scala is the language which is used only for Spark. No other environment use Scala language. So actually here Python. Okay. Python is dynamic type. It's a dynamic type. Scala, it's static. Yes. Dynamic type means yes. Generally here we no need to define any data types here. Generally here in Python, x equal to 10. What kind of variable x is means based upon what value you are assigning to x. If you are assigning an integer value, it takes integer variable is going to get created dynamically, right? If you are assigning a list, right? If you are assigning a list to this, as you have assigned a list to x, so the x is what? A list is created dynamically, right? No need to specify, right? It's a list or it's an integer, it's a float. Based upon whatever value you are assigning to it. So based on it, that is going to get created. If you are just assigning like a string like this, so you are assigning a string to it. So x is what? A string variable is getting created based upon what value you are assigning, right? So it's dynamic type. And frankly saying like not all the advantages you see in Python, like Scala also has got some advantages, right? So Python is slower. then Scala. Python is slower than Scala, and Scala is faster than Python. Faster than Python. See, 1 second. Scala is a scalable language. It is an extensible language, like it is extension to Java language. Here, Scala also uses JVM, right? Scala also uses JVM, right? Java Virtual Machine, right? So here, Python is an interpretation language, line by line execution. So as compared to Scala, right? Python is little slower as compared, but only that apart from that remaining everything, if you see, Python has got the advantages like that. Python has a huge community. It has a huge community, right? It has huge community. It supports nearly right. It supports nearly like 89,300 inbuilt modules for different environments, right? Yes. So whereas Scala community is smaller as compared to Python, right? Scala community. Okay. Python has powerful libraries. Powerful libraries, right? Yes. For data science, graph algorithms. Okay, but Scala supports, but less as compared with Python. As compared with Python. Okay. So advantages means in both the cases, yes, when we say Python is, yes, when we say Python is slower than Scala, it is in terms of slower performance, code executions. Yes, in the case of code executions, but this is interpretation is going to happen in Python. Like statement by statement execution is going to. But in Scala, we say dot Scala, like the dot Java file, right? It executes the entire code executes at once. So that's the only thing, right? Remaining aspects, everything Python has got the advantages. Means if you want to solve problems, if you talk about this, if you want dealing with any tasks, right? ML tasks or graph related or like data streams related things, right? So Python, even Scala has got, but it's as less as compared with Python. So main advantages of PySpark features. PySpark features. PySpark main feature is the main feature what we see in PySpark, in-memory computation. In-memory computation, right? Yes. In-memory computation is the main feature. Means if generally if we see even in the case of Hadoop, data is stored. See one side, data is stored within the disk and is processed. But in the case of the Spark, right? Data storage is happening within the memory, data processing also happening within the memory. So in memory computations, data is stored within the memory, means within the RAM. Data is stored within the RAM and data is processed by the RAM. That's why very high speed we say, right? PySpark has got very high speed, right? Even yes, about the speed of this PySpark, I'll come back, right? And what is the motivation towards PySpark and the speed of PySpark? So in-memory computations, right? Storage is happening and processing happening both within the memory level, right? It's RAM level storage and RAM level processing. And one more, lazy evaluated. PySpark is lazy evaluated. Lazy evolution, right? on demand, the flow executes. The entire data flow, right, executes only on demand. Otherwise, you're making any kind of action only, the entire flow executes. Until then, it won't execute. Just like a normal function, right? Like a function, if you make a call, then only the function executes. Generally, a function, if you talk, if you make a function call, then only the whatever the function you have defined executes. Until then, it won't execute. That is what lazy evaluated. Generally, if you take any statement, whenever you define immediately executing. Active evolution means whenever you define immediately executing. Writing, if you're writing 3 lines of Python code, the every code from start of the line to the end line. If you've got some 10 lines, from start of the line to the last line, everything it executes line by line. But functions, they won't execute until you make a call. But forget about the function. Just I have taken an example of function, but here it's a data flow, right? Yes. For example, transformation, T1 transformation. So this is your data set. This is your data set. On this data set, you operated T1 transformation. You got some output. Okay. On that again, okay. T2 transformation, T3 transformation. Yes. Okay. Fine. Means from the data set, A is created. On that A, you perform some transformation is applied. Some transformation you have applied. You got output. The output of this transformation is nothing but a B. On the data set, you operate some transformation, you got a B. A has got 10 lakh records. After performing the transformation, some filtering transformation, B will have 5 lakh, means 5 lakh got filtered. Some filter transformation we applied, the output is 5 lakhs. On that, you perform something, some map transformation or flat map, some kind of transformations you applied on this. The output of this will be the input to this. And the output of this on this B also, again, you perform some transformation, okay, by taking the input of A, and the output of B will be the input to C. The output of C will be the input of D. It's a data flow, right? The one output will be the input to the next. The one output will be the input to the next, right? This entire data flow is there. This entire data flow, whenever you perform action only, this executes. Until then, this is not going to get executed. This is what lazy evaluated. So this PySpark follows lazy evolution, right? It's an advantage. And it has got a powerful fault tolerant model. Powerful fault tolerant model, right? Yes. I'll discuss about this, lot of discussion on this fault tolerance. Yes, because even the data is important, right? So whenever your data is running on multiple machines parallelly, suddenly if any machine goes down, then there will be a data loss. If the data is sensitive data, like some banking kind of data, right? So how this Spark is able to recover that data, right? Processing is important, the time is important, that speed is important, right? So how this, how it has got the capability of regenerating the data, right? PySpark has the capability of regenerating that lost partitions. That is, it has got powerful fault tolerance. I'll discuss multiple cases in this fault tolerant. So what happens if the previous, while taking the input from the previous machine, if current machine is down, while taking the input from the previous, right? From this, the previous machine, if it is going down, right? Multiple cases I discussed. Yes. And one more feature, what you see, it is immutability, right? Immutability. So from A, B got generated. From B, C got generated. Yes. So immutable. All these are immutables, right? We have got RTDs and data frames, right? All these are immutable. The original RTD or original data frames are not going to get modified. But a new thing. So you got the concept of RTDs and data frames here. You got a data frame one. The original data frame will remains the same. It won't be modified. Just taking the output of it and performing some transformation, DF2 is created. But don't think within the DF1 only modification is going to happen, right? No. So performing some transformation, okay, after the transformation, right? Don't think the transformation directly applied on this. On the output, it is applied and a new data frame is created. Yes, means immutability. They all are immutables. Multiple data frames you can create, but the original data frames remains unchanged. It is immutable, right? Yes. And one more important feature, what we see is persistence. Persistence, right? Yes. Means data flow. Observe this A, B, C. From here, D, E, F. See this data flow. Yeah. G, H, I. And from here, J, K, E, L. Means this is flow one. This is flow one. This is flow two. This is flow two. This is flow three. Flow one, flow two, and flow three. In all this flow, first three steps are common, right? First three steps are common. First time you have executed flow one. Persist this, sir. Persist this, sir. See. So that second flow and third flow onwards, no need to execute from the starting directly. This is that already C is available to give its output. Use the C output and just execute only this flow for the flow two. For flow three also, this is that flow is enough. So there is a concept of persist. Is my screen visible to all now? Yes. Hello? Yeah.
Yes.
Fine. So the features like persistence feature means in the case of Hadoop, if any transformations output, if you want to make use the output of a particular transfer, reusing already executed transformation output is not possible in the case of Hadoop. But in Spark, if you already executed a transformation, it output can be reused. So just if you persist it, okay, you can reuse it, right? Yeah. Yeah. Fine. Persistence feature. Persistence is one of the important features, right? So one more thing, RTD persistence or data frame persistence means making it available in the RAM so that the next will be taking the output of this current one, right? So I'll be discussing in brief. You'll understand much better with some examples. Yes, main features are in-memory computation, lazy evaluators, powerful fault tolerance, immutability, persistence features. And one more feature is partitions, you see, right? Partitions. So the data set is going to be divided into multiple partitions and distributed across multiple RAMs of multiple worker nodes. Yes. If you talk about the real life usage, right, where this is used in a real life usage of, is my voice clear to all? Can
Yes.
anyone real life usage, right? Real life usage of PySpark. So in commercial sector, it's mostly used in the commercial sector, right? Yes. If we talk about Apache Spark real-time processing, we say real-time processing, especially in the case of banks and in most of the financial fields, they're using this PySpark, retrieving these customers' profiles, social media profiles, and analyzing to gain useful insights, which helps them in taking the right decisions. Yes. And even in the fraud detections, a real-time processing, we say, then and there, immediately it says that a fraud has happened. Even today in the healthcare also, right? Healthcare. Yeah. That it is used for analyzing the patient's records along with the previous medical history, right? Identifying that which patient is going to face the problem, right? That is performing a kind of analysis or prediction. Even if you see entertainment industry is using PySpark today, right? Like if you see the OTT platform today, right? OTT platform, the popular OTT like Netflix uses PySpark, right? For real-time processing, for personalized online movies or web series, right? It process nearly like this PySpark is going to process nearly 450 billion events, 450 billion events per day over the server side applications, right? Even e-commerce. Even if you talk about the Flipkart, Amazon, all these they are using this Apache Spark for advertising, right? For recommendations. People who is purchasing this product, also purchasing other products, some kind of recommendations is done, right? So it is offering some kind of enhanced customer experience and optimizing this overall performance, right? And also in this tourism, right? In the tourism, right, where Apache Spark is going to provide advices to millions of travelers by comparing the hundreds of tourism website. Yes, in the commercial sector, in the healthcare, in entertainment industry, e-commerce, tourism, and many more, right? Yes. Yeah. Even using this PySpark, right? Even we have got like PySpark SQL is a PySpark SQL, right? Yes. PySpark SQL is a separate module you see here, right? Which integrates relational processing with Spark functional programming, right? It is going to relate both relational processing and the Spark functional programming, where we are going to extract data by using you use SQL and we can perform some kind of querying, making the data structured and creating some kind of tabular structures and performing some kind of querying. The queries like even like pure SQL queries that you can use it, right? Even by creating data frames, after that creating data frames, creating temp tables, on the temp tables performing querying, right? Right. So yes. So here the main feature, right? In-memory computation, right? And lazy evolution, right? And persistence feature. Persistence feature. Yeah. For example, observe this flow execution. A is there. Data set. It is divided into multiple partitions. P1, P2, P3, so on up to P10. 10 partitions. They are stored in RAM. They are going to be distributed across multiple RAMs. Okay. So a data set divided into partitions. These partitions are distributed across multiple ramps of multiple worker nodes. All these partitions, 10 partitions, they are stored in 10 ramps of 10 worker nodes. They are going to be processed parallelly, and the final output is collected by B. This is the output. B is the output. The input of A, the output of A is taken as input by B. B, observe this B. B also, you are performing some kind of transformation of B, and the output of it is taken as input by C. And similarly, D. Observe carefully here. A is a bigger data object. A is a bigger data object. Accommodating this A is a bigger task, right? In RAM, you are going to accommodate this A in the RAMs, not in the disk. You are going to store this within the RAM level. So if you think it has got in TBs of data, GBs or TBs, A has got some GBs or TBs, right? TBs. It is going to be distributed across multiple RAMs, okay. But observe here, all this, this is of 1 TB, you think. This is of 500 GB, you think. 500 GB. Or this is also of 1 TB. 1 TB. 1 TB. A, B, C, D. Totally 4 TB. Accommodating 4 TB is a bigger task, right? That too in RAMs. You are accommodating 4 TB within the RAM level is a bigger task. So don't think here all the 4 A, B, C, D are going to be stored within the RAM at a time. No. A, B, C, and D, they are not going to be stored at a time into the RAM. So here, right, resilient distributed data sets, we say. RTDs, I'll be discussing in brief, right, in the tomorrow session. But resilient distributed data set. First, A only is going to be loaded into the RAMs of multiple worker nodes. A only gets loaded. One by one, it is going to, after A, next B gets loaded. After collecting the output of A by B, and once B computation is finished, A is going to be get removed from the RAM. Observe here, whenever B is computed and B has collected the total A output and B computation is finished, A is going to get, means A and A partitions or everything are going to get removed. Next, C collects the B output, and once the C computation is finished, this B, all this, everything is going to get removed now. B and its partitions. When D takes the output of C, see that how this internal computation of this, we have got Spark computation, right? The output of C is taken by D. Once D is loaded, when D collected the C output, when it is loaded and computed, see, once D, we need to get the final output of D. D is the final output. The final output once it is collected by the client, right? Once the output is collected, then D also going to get removed from the RAM. Now, what is present in the RAM? Yes, try to, yes, what is present in the RAM? What is present within the RAM? Nothing, right? So you got the output. One by one they are loaded. One by one they are computed. And they one by one they are removed. At a time, all those can't be accommodated. That's why we say data flow, right? The one output of one. Why we see one more thing, all these 4 A, B, C, D can't be executed in parallel. It's a data flow, right? Data flow language, what the output of one will be the input. The 4 of them can't be executed parallelly, because until computation is finished, then only it will get the B can get the input, right? Once A computation is finished, its output is taken as input by B. Once B is computed, once B computation is finished, its output is given as input to the C. Directly A and C cannot execute parallelly. Because once A and B computation is finished, until then C can't be executed, right? A and D also can't be executed here. But only one thing where you can see the parallel processing. A has got some 100 partitions. A has got 100 partitions. All the 100 partitions stored across 100 systems and are running parallelly. Yes,
So when you say computation
yes.
of each data set, what exactly going to happen there?
So
I mean, one small example.
whatever business logic means filtering. For example, on this A is your data set. It has got some 10 lakh records. Assume you got some 10 lakh or what huge data you got. On this 10 lakh, you perform some business logic, some transformations, some filtering operation you are performing. Some filtering means I want only those customers whose the balance is above 10 lakhs. Filtering only those. After that 10 lakh records becoming only 2 lakh records, right? In B, you will have only 2 lakhs. Means the business logic is applied in all these partitions. And finally, you will get only 2 lakh records. In B, only 2 lakhs means filtering. Means you are executing that partition with some logic. So there is a concept of in Spark, we have got a drivers and executor, we say, right? Drivers or executor. So driver will be the one here P1 partition, P2 partition, P3 partition, right? So later I discuss in brief about all this. We got data is divided into partitions. Who is going to provide a logic to this each partition logic? With what logic this has to be executed? Driver is going to provide a logic. Who provides logic to each partition? Means with what logic this partitions has to get executed? Business logic means driver provides. So execution of this partition with the provided logic is carried out by another program called executor. We got the concept of driver and executor in brief. I'll be discussing later. So partitions, if data is partitioned, so who provides that logic to the partitions? They have got a driver will provide the logic to each and every partitions. And who executes this partition? Executors are there. For every partition, one executor. For every partition, one executor. Means if you have got 10 partitions, means how many executors? Try to respond. Hello?
10.
How many? 10
10
executors required. 10 executors required. It will be only one driver will be there. Who provides the logic? Driver provides the logic to the partitions. Driver is going to provide logic to the partitions. But how these partitions are executed means executors are responsible for executing these partitions with the logic provided, right? Yes. So here also, whatever logic you are providing, based on the logic, they are going to get executed and they will execute, they will compute. The result, whatever is there, will be taken by B. So the output, whatever you get from this by providing some filtering operations, filtering condition you have provided, for example, the output, whatever will be taken as input. Yes. So here, all this can't be loaded at a time, I'm saying. If you've got a very big data flow, which involves multiple data frames or RTDs, right? All those, they are not going to be loaded at a time into the sphere. It cannot accommodate all. One by one after the other, they'll be loaded and they'll be computed. Okay, fine. See here, we see previously when this, if you go back like 10 to 12 years, in the where in 2011, 12, in the initial days where Hadoop was introduced, right? Frankly speaking, only the people who know Java used to learn it. Hadoop. Frankly speaking, right? The people who has got knowledge on Java, they only used to update with this Hadoop and Hadoop. Later in 2016, 17, when Spark came into the market, okay, they started using Scala. Now they are using means Java. Total implementation of Hadoop used to go using Java language. But you know, Java coding, lot of coding you see in Java. Lot of coding in Java. So what happened, if you see in 2012, 13, when Hadoop introduced, there was a big hype for Hadoop, right? But slowly people started migrating from Hadoop to different environments because of huge codings, very big, huge codings required in this Java programming. So totally we have got some technologies like Apache introduced many components, right? Like Apache Pig. Apache Pig, right? There is a very Apache Pig is a component, right? Where 100 lines of Java code you can write approximately in 6 lines. That is what simple coding you see. And it's a simple like Pig Latin language we used to say, right? There was a Pig Latin language where 100 lines of Java code you can write in 6 lines. Means whatever Hadoop uses MR MapReduce, where MapReduce uses Java coding. Hadoop total execution like happens within this, that is MapReduce execution. So total implementation goes in Java, but slowly that MapReduce, because of huge coding sweat, people started using Apache Pig, where very less coding, many inbuilt functions. Pig is also a data flow language. Pig is also a data flow language where it has got many inbuilt functions. Many inbuilt functions are there. No need to write any code. The single 1-2 lines, just 20 lines of Java code in 3 lines in Pig. So at that time, people started updated with Pig language, Pig Latin, right? But slowly, when Spark was introduced in the market, Spark is also a data flow, and Pig is also a data flow. So totally, the Pig got outdated. Apache Pig totally it got outdated. Now people are not using this Apache Pig. They're going with Apache Spark. Yes, but later even Hive, Apache Hive, right? It is still used in the market. That is for the component. So it has got many advantages of Hive, right? Yes, later. Okay, that is totally different discussion. But now Spark. But here, why I'm saying this, because even Spark, we talk about the Spark coding also, right? People, if you are migrating to this Spark environment or this PySpark environment, people also check what is that complexity you see in this writing codes in that, right? Very simple you see in PySpark, because here it is providing many built-in functions coding wise. If you see, right, it has got many inbuilt functions, we say actions, many actions, and inbuilt actions and inbuilt transformations it is providing. We no need to write any code. So all the inbuilt actions and transformations one by one I'll be discussing with some working examples, right? So no need to write huge codings. So people may get afraid, right, because of doing huge codings. So the language that we are using is Python. So initially for the next this week and next week totally I'll be discussing about Spark architecture, Spark computations, fault tolerance. Lot of discussions you need to understand, right, how this computation is going to happen actually. And later on, so when I start with practicals of this PySpark, immediately I won't go with any Python coding set. First, I'll discuss one by one actions and transformations. Later, combining both Python and Spark. Yes, we write many flows, data flows. So we have got mainly RTD concepts, resilient distributed data sets. We have got the concept of data frames in PySpark core, in PySpark core, right? Yes, in core program we got RTD. In PySpark SQL concept we got like data frames and even like DS streams for the streaming, right? Yes. Yes. If we see that what I'm going to discuss, right? PySpark, need for PySpark, real life usage of PySpark session, PySpark context, RTD, parallelizing, repartitioning, broadcast variables, accumulators, PySpark RTD computations, resilient distributed data sets, steps in persistence options, various persistence options, PySpark core computing, right? And groupings and aggregations. Using this group by key, reduce by key, there are inbuilt functions available. And what are the various actions and transformations, inbuilt actions and transformations? One by one, each and everything, what they are going to perform. And important topic like PySpark SQL data frames, Yes, making the data structure, data frame API, PySpark creating RTD to data frame conversions, and row class, column class, select with column renamed, where, filter, order by, group by, union, all this, right? We have got many inbuilt functions, one fill, null, pivot, and PySpark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, reading and writing into JSON file, right? And PySpark when EXPR, lit, split, concat, translate, overlay, to timestamp, to date, months, explode, array contains, right? Yes. Collects, list, all this. So many are there, we'll be discussing. And PySpark external sources working with SQL statements, Spark and Hive integration and MySQL integration, working with CSV, JSON transformations, actions, narrow transformations, wide transformations, adding new columns, dropping, renaming, right, handling nulls, joins, writing back to external sources, deployments, local mode, cluster mode, like PySpark applications, what are stages and tasks, drivers and executors, building Spark applications, deploying to cluster and tuning, performance tuning, PySpark streaming concept, integration with Kafka and Spark ML right? This is what in brief, in depth. So it is going to take time, right? So it is going to take time for this PySpark. We'll be discussing in brief with many working examples. Yes. So yes, the time duration for this, right, for discussing all this PySpark, 10 to 12 weekends it takes. Yes. And as I said, everything goes in Python, right? Yes. Yes. Fine.
Sir,
One second. 1 second. Yes. Any query? Yes.
sir, when will be our class in back in original time 2:30 or all will be going to happen at 4 p.m.?
Yes. 4 p.m. So PySpark, yes, 4 p.m. is the PySpark, right? It goes for everyone try to attend this batch. So it goes for next 2 months to 2.5 months. It goes. Yes. And one thing is, I request that everyone should be regular to the sessions, PySpark, right? Because regular to the sessions, I want the sessions to be interactive. So whenever you are doing the practicals, like whenever you're done with the practicals of today's session, the next session will be very simple and easy to understand. You can easily respond, right? So everything is interrelated. The Spark execution model, right? Yes. And even if you see that the course content is also, it's very huge. We'll be discussing with many working examples. So everything I'll be typing and showing you. Any queries you got, you can ask me. You can unmute yourself and ask that queries through eyes, or you can, but one thing is interaction from both the sides, not just me just saying that and going off. Okay, fine. And actually the computations, so I'll be starting from tomorrow, right? Today was just introductory session, and just someone was just, let me show you that speed. So already if you talk, there are many tests done, right? Yahoo has conducted a test, many tests were done to check the speed of different databases, right? Yahoo has taken a table of 100 TB to check the speed of various databases consisting of 1024 columns. The task was sorting. Based on 16 columns. Task sorting based on 16 columns. Time taken by different databases. Time taken, right? Yes, performing this operation. For sorting based on 16 columns, right? This 100 TBs of data. Yes, Oracle. It's taken nearly 3.5 days. MySQL. Taken nearly 6 days. Sorry. Okay. Specialized database, right, like Teradata. It's taken 3.5 hours. Netija. Sorry. Taken 4.5. Hadoop has just taken 3.4 minutes. Okay. Minutes it has taken days of time, hours of time, but it has taken just minutes of time. One second. Yes. So prerequisite for learning PySpark is only Python, right? Python, I need to have some basic knowledge of Hadoop. So HDFS. Everything goes in Linux environment. Everything goes in Linux environment, right? You need to have Linux. You need to have the basic Linux commands knowledge, HDFS, right? Basic SQL knowledge and the Python, basic Python knowledge, basic SQL, basic Linux for all this, right? So everything I'll take care during this practicals, right? Remaining all. Even one session I'll take totally to show you all the syntaxes of total Python, right? And people who doesn't have knowledge, like basic at least HDFS knowledge you need to have of Hadoop, right? People who are directly coming to PySpark, right? So just I can forward you the notes of HDFS commands. We can go through that if anyone if doesn't have knowledge on HDFS, right? That is where the data storage. Okay, but here Hadoop has taken 3.4 minutes as compared with days and hours of time. See the speed of Spark. Spark is 100 times faster. 100 times faster than Hadoop. Spark is 100 times faster than Hadoop in the case of memory, like the case of disk, it is 10 times faster. 100 times faster than Hadoop, right? So that is, yeah, PySpark. So it has got very high speed processing rate, even as compared with Hadoop, right? So there were many Hadoop components which got outdated, right? But whenever people who already are attending Hadoop, which are mostly used in the industry, those components I'm discussing. But most concentration will be on PySpark, even in the industry also. Even if you have got knowledge on Hadoop and PySpark, many questions or queries will be related to PySpark only. 98, 70 to 80% of the queries will be on Spark, PySpark. Yes. So how this concept of RTDs, I'll be starting with the RTDs, resilient distributed data sets, right? And how this computation is going to happen, right? Fine. Yes. Any other queries you got, anyone? So Apache Spark, PySpark, need for PySpark, and
So Yahoo did the same test on Spark. Exact time what they got?
pardon?
Yahoo that experiment by Yahoo was it done on Spark?
Yes. See here, what you're talking about this, right?
Yeah.
Time
So
taken. Yes.
yeah,
So this is what
what was the
no,
time
no,
for
no, no,
Spark?
no, that is not. I'm not talking about Spark. It was not done, but Hadoop, whatever Hadoop
Oh,
speed
okay,
you have
okay.
seen, right? You have seen Hadoop speed, right, as compared to the other things. But
That
I'm
time
saying
Spark was not there.
but Hadoop speed is already it's much faster than as compared to other. But if you
Yeah.
compare Hadoop with the Spark, right? So
Okay.
why you may ask motivation towards Spark? Previously, if you say yes. Spark is that much times 100 times faster than Hadoop. Hadoop speed is already faster, but still Spark is very high speed, right? Yes. Fine. So today just it was introductory session, right? So tomorrow we'll continue more discussion on this. Tomorrow I will just go with the technicals of first in the how this competition is going to happen. RTDs, what do you mean by RTDs? How this RTD computation, steps in RTD computations, persistence options, fault tolerance mechanism, different ways of creating these RTDs. So before we go with the practical part, right? Yes. Yes. Fine, right? Yes. Tomorrow also, everyone, you can follow the same link of today's at same time at 4 o'clock to see more discussion, right? Yes. Fine. So I'm stopping for now. We'll continue tomorrow, more discussion.
Sir, I have one question, sir.
Yes.
Sir, I am part of this 230 batch. Okay, Hadoop 230 batch.
So,
So the Spark,
yes,
Spark session I need to attend at 4 o'clock, right? Hereafter.
yes. Everyone,
And one more.
yes.
Yeah. Okay, sir. Please proceed, sir. You were saying something.
Yes. There is only one PySpark batch starting, right? Previous
Okay.
previous PySpark was started in the month of December. Now the new PySpark is starting. The next PySpark will be again after 2 or 3 months.
Okay, sir. Sir, and one more thing. Actually, in the drive, the recorded videos, last three
Okay.
Sunday videos
Yes,
are
yes.
not
So
uploaded, sir.
let us have technical discussions in the session during the class, right?
Okay.
Related to that, videos or drives or related to those things. You can give message or you can talk with online team. Right? Otherwise, you can message in the groups.
Okay. Okay, sir. Thank you.
Right.
Sir, there were few questions in the chat.
Streaming data, yes, SAMP, right? PySpark optimization and streaming you're talking, right? PySpark streaming, I'll discuss. I said also, I'll say integration with Kafka, right? Kafka is a streaming component, right? Which is mostly used in the industry, right? And PySpark computation with Kafka streaming, I said I'll discuss. Yes. Yeah, deployment strategy, yes, I'll be discussing this. Yes, Uma Mahesh. Yes.
Yeah, thanks, sir.
Okay, fine, right?
But Vijay, as part of this session, right, will there be any, like as someone mentioned, right, debugging strategy or deployment strategy? I see that
Yes.
the deployment strategy is covered, but is debugging?
Debug is not a big thing, right? I can cover it. Okay, fine. Okay,
Thank you.
yes. Okay, we'll continue tomorrow, right? Yes, same time at 4 o'clock. You can follow the same link.